Okay, let's get started. Welcome all to today's seminar. We have again Daniel Sempere Torres. He is professor at the University of Politècnica de Catalunya in Barcelona. And he is also the director of CRAHI, which is essentially the Center for Applied Hydrometeorology there that he has established and done a lot of successful work there. He got his PhD back in 1990 in France, in Grenoble, and then went back to Spain and has been there ever since. Some of you may remember that the Boulder flood in 2013, Daniel brought it with him. He arrived here, and the flood was unfolding, and he was like in heaven. Even though the place he was staying was affected by the flood too. But so he is actually a co-author on that paper that Dave Gotchis was the lead author at the time. And so he clearly knows what flooding means and how to communicate risks, do end users, work with end users, help develop early warning systems that translate essentially weather and hydrologic information into impact and communicate it in a way that make it actionable to stakeholders like emergency manager or the broader public. And so that was particularly focused on the flooding. Last Wednesday, the seminar that is recorded, you find it on the RAL website if you haven't had a chance to be there live. And so today we are expanding on this, entering more the climate-related arena in terms of how to make use of information that's out there and translate it again into actionable capabilities that the stakeholders can benefit from. So please, Daniel, take it from here. Thank you.
Thank you, Matthias. Thank you for this nice introduction with the remembering of the Colorado floods. And as he has said, last week we have had another seminar more oriented to the early warning systems and how we are developing these early warning systems together with a number of early adopters that are emergency managers and thinking about how to communicate better. Because what we found is that in the last events, in some of big events in Europe, here you have also the one in Texas, the system failed into making this warning happening and be useful for the people. This was last week. Today, I am moving to tell you about what we are doing in Europe for bringing this climate change awareness and need of adaptation to the local level. The question is how we can transform what we do in climate science into local action. And one of the most important things that usually we don't pay enough attention is how we can communicate our findings. And I put this example because I think this is a very nice example, how the evolution of the increase in the temperature moves across the time at the global scale, these stripes, climate stripes for the globe. And it's a nice, for me, way in which you can try to transmit all these things to a population that it is interested but probably cannot follow all the details. Also, we can do even better. For me, this version is even better because you use the colors, but you can also see the evolution of the anomaly, and you can understand much better the importance of understanding, be aware, and start reacting to this climate change that is already affecting us. And there is another graphic that for me is also quite interesting, is if you put the same strip color bars following the curve of the atmospheric dioxide carbon concentration, and you add at the top the international achievements or meetings or decisions. And you can understand how on these increasing times of the atmospheric dioxide carbon concentration, we have and really a connection with what is happening at the level of the temperatures in the globe, and the failure, let me say like this, on being able to agree and act as a global level. All this is just to show where we are. Of course, you know, and you are probably aware and interested in all that. You are not to be convinced about the importance of climate change. But one of the things that now, last year, we confirmed is that we are already over 1.5. We have reached the threshold of 1.5 degrees over the pre-industrial level. And if you remember, in one of the IPCC's reports in 2017, it was this kind of graphics in which the question was if this 1.5 degrees was a reasonable scenario that we should keep not going over. And when you see at this time, the warming rate was supposed to reach 1.5 in 2040, when we know that at 2024 we have already over. So when you see these kind of things, that mean that even the scenarios with the uncertainties are overpassed by the reality, by the present reality. We are even worse than these scenarios and their uncertainty were thinking that we will evolve. So this is the moment in which adaptation to climate change starts to be so important, because we failed in the past decades to do a mitigation program that could help us to not going in that direction. So now the alternative of starting adaptation is quite important. And this is what we have understood in Europe. And the European Union have 5 missions up to 2030, in which means that money or funding will be dedicated essentially into these EU missions, especially for what the research is. And among these 5 missions, you can find cancer, and everyone understands why the fighting against cancer is so important. So another of these missions is adaptation to climate change. So for the European Union, this is at the same level, and I think it's interesting. From this European mission, at least what they want to achieve is that 150 communities understand fully what is the new climate risk and start developing pathways for preparation and adaptation, because the belief that is behind is if we have a certain number of applications and local communities that move in that direction, this is the way in which probably the others can replicate and understand better. Adaptation, as you know, means an important change at the societal level, because we need to adjust to climate impacts in ways to reduce vulnerabilities, and that means change the way of life. In certain areas will be because the sea level is rising, in others because the water is scarce, in others because the wildfires will increase. So the different realities that are behind climate change will move to different adaptation strategies. And when we look into what means adaptation, essentially it means a number of steps in which you understand which is the increase of the impacts related to your normal risks due to this climate change, and you try to understand what to do this adaptation. An important step ahead is the assessment of the new risks. And this is what is supposed to be the first step, what we call climate risk assessments. And to do this is the first step to initiate the adaptation. It's the way in which you can be aware about the changes in your risks that will happen. But these impacts are local. So we cannot do this at a very high level. We need to go up to the local level to understand these changes in impacts and these changes in the life there to be adapted that we will need in the future. And the question is how we can support regional and local adaptation to climate change. And this is what I want to present today, the ideas and the implementations we have done in this project that it is called CLIMAAX. And how we pretend or we are trying to organize a massive implementation in Europe, that it is the second step. The idea is that from this EU mission, Adaptation to Climate Change, they have funded this project, CLIMAAX project, with two objectives. The first, to propose a methodological framework and a supporting toolbox for guiding regional and local climate risk assessments. So preparing the tools for helping the people. And then select 50 municipalities at least. We have selected 69, so at least go over 50 municipalities and communities and fund them to implement the proposed methodology. This is a little bit revolutionary, I explain you. The people at the Euro and at the mission decide that normally when they put money to fund some action on the table, the same actors are taking all the money because, all this is difficult. This is not easy for small communities or municipalities to get access to this funding. So they decide to change the way, and they use an instrument that it is financial support for third parties. So the projects under this instrument get money to do the initial project, in our case, to propose the methodological framework and the supporting toolbox. This is a development. We need to develop this. This is a part of the budget. But then we have a second budget that it is supposed to be distributed among third parties. That means that a significant amount of the funding for the big project, in our case 12 million euros, should be distributed into third parties that should be selected with a selection process, with criteria, etc. To bring a significant part of money, that in our case is around 180 kilo euros, directly to that partners that wants to participate, that are early adopters, that are prone to work on these kind of things and test the solutions provided, but they normally don't get the money because they are too far from or not well organized enough to get the money. And this is quite revolutionary, quite interesting. We will talk later a little bit more. But this is just to present you the idea. The idea is that we need to evaluate the present risk in a given place and then use the climatic information to calculate or to provide an evaluation of which will be the future risk, measure the change in the impacts, and start a process that it is very complex. That means be aware, use this knowledge you have to prepare your population to go in the direction of the adaptation, that it is very complex. But at least the first step is what CLIMAAX pretends to do. Provide these tools and help and support the 68 regions and municipalities doing the work to apply the test and test the facilities. CLIMAAX is supporting two lines. The one is trying to support the adaptation of the risk management plannings of the civil protection authorities, because the plans to manage risk normally are based on the past experience. But now we know that the future will be different. So the risk management plans should take into account these changes that will be produced due to climate change. And the second, to help these communities, municipalities, groups of people that are interested and engaged to do this study of which are the changes in the impacts in the next years for their activities. So CLIMAAX has proposed a methodological framework, very nice, following more or less what is done by everyone and with the EPCC recommendations, and then is proposing for doing the first stages of this climate adaptation process some tools that we will put together in a toolbox supporting these calculations. All this is accessible through the handbook of CLIMAAX have prepared. It's a nice exercise of putting all the information together in a web and putting also the tools that you can use. And of course, all the knowledge that there is shared, and it's common because the definition of risk, how you calculate your hazard, exposure, the vulnerability, all these things, but it is material that has been prepared for being used by people that are not experts. So it can be interesting to you to get a look. And then we have derive a number of what we call risk assessment workflows that help the people that are using these tools to calculate the change on the impacts on the different risks that can affect them. There is 11 operational workflows for 7 hazards. That means that for same hazards, you can calculate the impacts in different ways and the different scenarios. You can find all this in this handbook CLIMAAX place. The idea what is, for the different hazards, what we have is a methodology to assess the increase of the impacts. More realistically, less realistically, depend of the hazard, depend on many things, because as you know, inside what there are is we take the climate data from the climate models, and we know that sometimes the climate models are just approximations or have an uncertainty that it is enormous. But at least we can do this in a simplified way and helping the people that are not used to calculate some indicators for their location. Can be local, can be regional, can be national. So for every hazard, we have defined a set of climatic indicators related to the variables, the triggering variables that these different hazards, and then we have proposed some calculations. Some of them are pre-calculated in the past using reanalysis for the past period, and then for the future period with the data that are available. Normally, in the case of Europe, you use the Eurocordex non-biased estimates for the next decades, for the next years, and we can compare. So in this way, you have an indicator that probably is helping you to understand your risk, and you can compare the past with the future. And for instance, one that we have used and is very clear is the number of nights in which you will be over a threshold, normally what is called tropical nights, and you can see the evolution in a given month in the past or in the future for this number of tropical nights that in your location can happen. Of course, we know with all the limitations of the climatic models, this is there. We cannot do better than this. Every workflow has different implementation, some more limited, some more general. The workflow should be simple enough to be accessible to all users, but at the same time complex enough to allow some deeper analysis. There is an executable in Jupyter notebooks that can be used as it is. You can reprogram because you can download the Python code and change the things that you need to change, or add lines to make it more at your own. So it's a facility what we have developed there to make this possible. In the CLIMAAX Toolbox and all the developments for sure are open source, free and available to anyone. You can go, and even if it's just for curiosity, you can look at the different things. And there is a repository of the initial code in GitHub that can be moved through the Docker to the Jupyter Hub. There you can interact. This is more IT concepts, but probably you know, or if not, it is something that it is more or less a la mode. And you make possible that the people use or the code that they see as it is, or they can change and, for instance, change the scenario or change the regional model you are used, or adding local variables or local information they have. So all this is facilitated. Let me explain you one of these workflows, the heavy rainfall one, that you understand better what we are doing. Essentially, what we do is first a description of what is inside, and we try to communicate the procedure to the people. In this case, there is a guidance to develop critical rainfall thresholds. The underlying concept is that if you live in a given place, you can see in the past that you have problems when it rains over a certain threshold, because the road is flooded, because the highway is collapsed, or because anything that is experienced in a given place. So the idea is that we need to characterize these thresholds. When the system fails or have big problems, big impacts, it's not necessary to quantify the impacts in economical basis. It can be very simple, because you are thinking on helping a lot of municipalities to do to replicate this work. So first, go past, look, and try to understand over which threshold you start to giving problems with the heavy rain. Then you calculate, and this is done on the workflow for you, the different frequencies for different thresholds in the past, in the future, with the reanalysis, with the Eurocordex projections for different projections. And then once you have this, you can start seeing and starting thinking about what happens in the future if my threshold for getting impacts is set to the value I set. And then we can discuss on the course what will be the needs for the adaptation. All this is discussed on the material of the supporting material included, about how to select the critical thresholds, which are the three critical thresholds for different levels of impact, allocations, and recommendations to use this concept. But for understanding better, what you have is a city that in some of the streets get flooded when in the past a threshold of 30 millimeters and 30 minutes are recorded. And we know, because it has passed many times, you can assign a frequency, a certain year return period, in this case 10 years. And the question is, how do we manage the expected change in frequency and magnitude due to the climate change? The first idea is that if you want to be safe, what you say is, well, the threshold will not change because my physical reality is related to this threshold. I will continue having problems anytime that I will record 30 millimeters in 30 minutes. The question is done, which is the change in frequency if I keep the same intensity for my threshold? And in this case, the climate change normally will give you a response that it is related to a reduction of your frequency. So these kind of situations will be more frequent. Using the different scenarios, the different regional modeling, you can go to establish which is the change in the frequencies in your city for this given threshold. In fact, the threshold, the selection of the threshold is including the vulnerabilities. So the analysis is simplified, and we can go to play with all these workflow and climate models in a way that you can understand the effects. The contrary case is to say, well, I don't want to change my frequency. I want to keep the 10-year return period, because if not, my citizens will claim and will be against me as a major, because we are flooded much more frequently. So in this case, we can go to the workflow and look for which is the intensity, the new threshold that you will have if you try to keep the frequency. And all this that it's very simple, let me say like this, all this reasoning can be supported through the workflow to get values that are meaningful for you. And in this way, you will have probably that the new threshold, keeping the frequency for you in 30 years will be 45 millimeters and 30 minutes. That means a much more bigger amount of water that you need to put somewhere if you want to keep the same effects for the same frequency. So this will move you to look or think in adaptative measures. That means looking for money for building infrastructures, hard infrastructures, nature-based solution infrastructures, whatever, but you can quantify, at least in a first stage, for your municipality, which are the needs, if you want to keep this at the same frequency. So this is the way in which we are trained to do the things. If you have not the money to do this, well, then the basic solution will be to let the people know that this will be the new reality and we need to adapt. If we cannot change the volume of water, we will have more water more frequently and we will need to adapt to this new situation. The toolbox can also provide some graphical outputs. It can help you because the code is there. You can download and change and adapt and include refinements if you go there. And it can be applied for different hazards. This is a graphic on the number of heat waves per year in a given place, or you can move to fire index risk and how this risk will evolve. We have had, I didn't found, but a nice way to apply this, that it is looking the main roads of a region, which is the change on the vulnerability or the impact over this portion of roads due to potential wildfires in 30 years. So you will have the routes that are never close to the possibility to have a wildfire around will move to bigger probability to have wildfires. And all this way to express the calculations, it's the part more interesting, at least for me, but more difficult. Of course, there are plenty of limitations. When you go to these temperatures to see the number of nights in your city that will be tropical in 30 years, we are hiding that behind there's a neurocordec pixel of 0.11 degrees of resolution, that it is very coarse. But this is the regional modeling for climate change. So models. We need support, or in the future, because it's hard to think about how to downscale or use local data, because this pixel, when you go to the reality, the distribution of temperatures for a same value, for an average value of the pixel, the temperatures are totally different inside. So if we want to go in detail to the heat waves, we need to put a lot of information more. This can be done if some of these third parties are interested, because you can use a map, a topography map, a map of vegetation with very rich resolution. And even if the climate projection has not, you can combine them to get a map of potential new temperatures because you take into account your local vegetation, or you can go to vulnerabilities. This is a map of the population over 75 years that lives alone in Barcelona. And as you can imagine, this has a very important impact on which are the impacts or the consequences of a heat waves, because this is the population that it is more vulnerable, and if they live alone, they are still more vulnerable. That means that the map of the temperatures is not explaining which are the impacts at the end of the day of a heat wave. You need to go really local to understand all the chain. This is not possible at the scale of the project, but at the scale of the project, we can put some examples and then let the people do as far as they can. This is again the climatic indicator of heat waves in Barcelona. You can see that if you go into the details, you can look due to the quality of the buildings, the buildings that have or not air conditioning, the different things that make that the temperature, the initial temperature from Cordex can be changed into something more interesting, and even you can go to daytime and make maximum temperature maps, making different impacts, or you can introduce this population over 75 years and get a vulnerability map that in the case of big cities can be very structured and very high resolution. All this is behind. All this cannot be done if you are just in a workflow pretend to be applied over the entire Europe, but we can encourage the people with these examples to do then at their own. The second step, once we prepare this, was to make this selection of early adopters that wants to apply. And this offers a very nice opportunity, because if we have developed the workflow and we have put all this information inside and we think that it is clever to do these kind of things, we will see this replicate in a big number of places around Europe. So this is really interesting. We find 69 regional and local applicants with an average grant of 180 kilo euros. And for doing that, we have had 2 open calls. We made a first one in which we tried to prefer the regions or municipalities that were more vulnerable, and a second one that was like a gap filler to try to compensate the ones that have been excluded in the first one, and to try to cover all the territories. What they have been asked to done is a 3 phases work. In the first phase, they apply the common methodology of the project, the toolbox, the framework, and in the second, they refine the findings with regional, local, high-resolution data analysis and risk assessment, all what they can do, following these examples that if you go in a fine resolution, you can get better measure of your impacts. But the first one is like a baseline that can be comparable along all of them. The second, it will depend on how much effort, how much interest they put, and we will have a big diversity. And the third is try to use all these to at least identify next steps to at the end of this process to have some information that can be used to look for adaptation measures or for new funding for putting these adaptation measures. This is the full work they should done, and for doing that we run these 2 open calls, and you can imagine there is an application process. We need to explain the work, the interest, to motivate the people, to get applicants through this process of application. Then it was the evaluation of proposals, the selection of these early adopters, and then a sub-project and agreements to make a contract between the project and them to make possible the support, the financial support for third parties. The result is that we have had in total 382 applications. That it is a very good number for us. We were thinking in between 100 and 200, so the process was very good. We selected 69 applicants with different number of regions, and then we can see the two places or the two calls results in terms of countries, but we can do this in terms of regions. So we have 69 from 54 regions. Regions in Europe is quite complex because, as you know, Europe is a collection of countries. Any country is different. Any country has their own definition of regions. And in Catalonia, my region, we have 8 million inhabitants, whereas some of the countries, the full countries of Europe, has less than 5 million. So there is a diversity that it is enormous. But there is a way to count the region depending on which country you are, and we have 54 regions and 23 countries represented, more or less distributed with a big concentration of the south for two reasons. The Mediterranean areas are more affected by climate change now, so it's easy to make them move. And the second, normally the north regions in Europe are richer, and they don't need this support to do these kind of things. So they are not motivated as the people from the south are, because probably for them, if they don't use this money, they will have no funding for doing this kind of climate risk assessments. But it is nice, and I can promise you we are so happy to have this in place, because it's 69 municipalities that want to apply your workflow, your ideas, and see what happens. And of course, the results will be not at the level of what as a scientist we are expecting. This is for sure, but it is the real world. This is reality. The difficulties are enormous to do this kind of stories with your thresholds and with the future and whatever. But they are also finding all the problems we have in the workflows and in the developments, and they are very aware about the limitations and very critical in the positive way. So we are collecting a number of ideas for the next steps, for the next future. So these implementations are key to explore how to convert these toolbooks in a real support, because this is the first exercise we have done. It's like, we think that this will be helpful, but we don't know. Now we can follow them, and understanding the real needs and requests from them will be very, very important. And I moved to this cartoon that they mentioned in one meeting in the week with some of you, that it is normally we have an approach that it is like this, no? There is someone that it is doing hard work, and there is someone that approach and let's introduce his ideas to improve. And normally we are thinking that the end users, the stakeholders are the people that do the hard work, and the research and the enterprises, the small, medium enterprises, technological, are the ones that have the solution. But when you approach the reality, sometimes this can be changed, and sometimes this hard work is done by the researchers that try to figure out how to do all these things, and the people that are close to the real life have some ideas that can be useful and implemented. And if you understand this joke, you can understand the importance of doing these kind of things. And let me go to this CLIMAAX workshop we had in Barcelona in June, in which we put together all these third parties implementations. Anyone was presenting a poster, and it was very nice because they tried to summarize their findings into the posters, but also it gave the opportunity to all of them to express, among the others, what were the difficulties, their findings. And then we went into a situation where we selected success stories from them to be presented, and also a session of questions about how to improve, how to change the things. And it was a very nice opportunity, because really when you go with them, when you meet all together, you find this energy that comes from the real applications, that it is, even if the workflows are very limited in many aspects, you are trying to help them to do something that it is useful at the real life. And it was really an occasion in which we enjoy very much. It was really a burst of energy, and is where we are. CLIMAAX is not finalized still. We will run up to February 27, and we only complete the first phase, the application of the workflows. Now, their application with their local data, high resolution, or their own knowledge will come, and this will be a big opportunity to understand how all these municipalities can understand and do better of what we have done in the first stage, and take profit of all this to make a step ahead. Lessons learned. Let me say that the first lesson I can share with you from all this process is that we are used that climate models offer outputs that are essentially how the variables of the climate model will change. But this is not good for the reality. About the wind speed, the temperatures, the humidities, this is not talking in terms of impacts. So we need a second effort to make that this climate risk assessment will include the translation of the climate model outputs into impact-oriented actionable indicators. And when you discuss with them, you understand what this means. It means that if you are talking about fires, it's not the temperature. For instance, it's how long the wildfire season will be in 30 years, because that means a lot of implications for the planning, because I will need more people, more over the entire year than just on the summer. Things like that are really changing the mind, because this is not done easily by the models, that needs some assumptions, some computation, some clever work behind to translate this into something that it is actionable. And this we have the tendency, all of us, to forget, and this discussion with this local level with the end users helps. Then it's easy to say, well, we are multi-risk because we have multiple risk on the workflows, but we are not really multi-risk. It's really a challenge. And the reality is that sometimes all these impacts are together. High temperatures, low humidities, winds, high winds, it's for fires, but it's also for droughts or different aspects. So this is something that in the next years we will need to work really hard, because it is not easy to propose an analysis of risk, really multi-risk, but this is something on the list. Then, improve vulnerability estimates. I think that the vulnerabilities remain the least developed component of these climate risk assessments, because we are using proxies at the end of the day. The easy things are GDP, density of population, things like that. But if we want to really assess well the impacts, we need to go into dynamic between one day in the week or the weekend, the summer holidays or the winter period, sector specific and locally validated, because some of these indicators, when you approach the people at local level, is not what they need. As in the example of the heat waves, there are many of granularity, a lot of granularity in these indicators that should be put there, that it is not comparable with the resolutions we have on our climatic modeling. But we need to understand that there is the need of a fusion of all this to make it happen in the impact-oriented indicators. And the toolbox, we need a more user-friendly interface. I don't know if you are familiar with Python, Jupyter Book, and all these things. Probably of you, yes. But it requires a level of IT knowledge and ability to be exploring all this and learning Python and all these things, that it is not the normal world. We need something much easier, much adapted to the use of non-IT specialists, including enhanced graphics. This was the first trial. It's like it is. Probably is inspiring to some of you or to other people, of course for us, but we know there are big limitations that should be improved. But the one thing that we have found that it is very interesting is that we shape this financial support for third parties in a way that we are only accepting proposals from authorities. That means that the one that wants the project and get the money is an authority. It can be a municipality, can be a regional department for climate adaptation or for flooding, can be even a community or group of small municipalities. Sometimes the municipalities are so small that they need to be grouped to do things, or a group of agricultural lands that they are worried about, which is the impact of the droughts in the next 30 years on their activities. So they need to be like someone recognized. Universities cannot be the consultancy firms, but we allow them to subcontract. So the normal grant they receive, a part is for the, let me say, municipality, but probably a big part of the grant is subcontracted to this university group around, to this consultancy firm around, to some specialists that they know. In this way, what we have seen is that this money goes to a local authority, a local municipality responsible, that then select around them who is able to help them. So we are transferring the money in a way that we are creating a full ecosystem of technical actors supporting these different municipalities. It's not money for 69 municipalities, it's for 69 municipalities and 69 experts around them. And this level of capillarity is impossible to reach from an European or a federal money funding agency, because you cannot detect who is the best people to help this municipality. Along this chain, we have identified not just these early adopters, but the people that can help these early adopters. And the purpose is to continue support the system, because then this consultancy firm, this university group can not just help the initial municipality, can extend the support for many other municipalities around that initially we have not reached. So we are incubating, let me say like this ecosystem for adaptation with a reduced money. At the end of the day, it's only 12 million euros, but through this program, it's making, I think, a help for the entire Europe. Thank you very much. If you have some questions, I will be glad to.
Thank you, Daniel, for your forward-looking, visionary, stimulating presentation, and actually showing that it can be, put in reality, put to work. And in many ways, you have been pushing boundaries on the European level in so many ways, and this is just another example. But I don't want to ask all the questions here, so please, from the audience. I think you should be good that the microphones are picking up.
Thank you, Daniel. This is a very interesting, very beautiful talk, and especially the cartoon you show, there could be role switching, and I wonder through this exercise, what is the best top 2 ideas that you actually collected from your kind of stakeholder participants, and what are the most criticism or the problem that they identify through your toolbox system. So I would like to just hear some of those examples.
Thank you. No, the idea of working with them, it's the first stage. This is why I put the cartoon to make it more evident. And we had a lot of discussions and a lot of questions collected. I think that essentially I tried to put these main ideas here in the lessons learned. They accept that the limitations are there. They are asking for going further in that direction. That is very clear. You are telling me something that is not helping me. No, if you give me the unexpected water level for a river flood in 30 years, well, I need a lot of computations behind to understand what that means. I need something that it is close to my reality. So this is the first one. Then, of course, the resolution of the models, the uncertainties, the difficulty to understand uncertainties is a key question from them. And it's difficult because it's challenging us how we can make all these uncertainties more meaningful. Because at the end of the day, the decision should be made independently of the uncertainty bounds. But we know that the climate modeling, it's far to be something accurate. So these are main things. This multi-risk perspective, also the way in which we show the different hazards, because the toolbox is not very advanced in graphic support, and they have asked for a better enhanced graphics, and specifically that you can overimpose the different hazards in the same final graphic to see much more this multi-risk component. There are plenty of them. It's not easy to summarize. I try to summarize with this. Also the vulnerabilities, but we know this is when we do the risk analysis, we know that the vulnerability part is our weakness part. The hazard we have understood more or less, but then exposure, well, with the maps we have and the statistics we can do, but then vulnerability is something that requires much more attention in the next years. So essentially try to summarize here.
Other questions? Olya, I see your mind is cruising.
Sorry, can I ask one?
Sure, go ahead.
So you said that thank you for the talk. Yeah, it was really nice. You said it's like around 180K euros for each of those
Yes.
programs. Yeah.
It is not very large.
Yeah. So these are supposed to be given to like universities there, or to kind of customize or tailor your toolbox for their own region, or
It depends on the case. There are cases in which they use the money out of for the institution. That means that they have in-house some technical people able to do this, but the majority don't have in-house the technical people to go through the details of the workflows, the Jupyter book, the Python. So they are giving a significant part, let me say 100,000 to an external support. For this external support, 100,000, at least in Europe, is a decent money, because normally when you are in the live world, you do a lot of work for even less. But this helps them to understand all these things, and even develop how they will take local data to refine the first phase. So they are probably developing a capacity that then they can offer to other places around, other municipalities, for instance, because all the municipalities will be on the same problem. So this is like a question in which you invest to do the first work, but you know that probably it will help you to be able to add as a skill this service on climate change adaptation. So this is more or less the situation. This is not a big money, but for the majority of municipalities in Europe, this is a significant amount.
And the final outcomes would be like some adaptation strategy for their.
What we require is 3 deliverables from each one of them. The first is the application of the toolbox and the methodology for CLIMAAX as it is. Second, a refinement with local knowledge, data, and process. And then a third deliverable on this connection, as you said. We don't know, we are not yet there, if they will be able in a majority to get up to the identification of planning or strategies for adaptation. But at least if they can document with a certain level of quality that they have some results that move them to look for a solution, an adaptation strategy or something in the future, because in 30 years the temperatures, the impact of the fires or whatever, it will increase. The heat waves, this is a big problem in Europe at municipal scale. They can start. There are things that can be easy. There is all these climatic refuges. I don't know if in English is like this. That the municipalities are creating for the heat waves, places in which you can have cold atmosphere and what. This can be easy, and you can try to plan which is the number you will need in 30 years or 20 years. So some of them will be reality, but it is difficult because it's a huge variety of cases. We will see. This is coming.
Thank you, Daniel. There's another question online, if I may take Jonathan Weiss first. He says, thank you, fantastic presentation, and he loves the project. And he says there is an art to meet the needs of the users through the data that are available, and they don't always match. And so he's really wondering, based on your experience connecting to so many diverse communities, have you been surprised in one way or another what is coming back out of this?
I think that if you ask me for what I'm surprised for, it's for this amount of good, positive energy that you can find of them, because they are understanding better. And their capacity to accept that the limitations are there. The resolution limitation, the workflow is producing graphics that are not very nice or whatever. But in fact, they are seeing this as an opportunity to understand better, to be more aware, to have tools to convince all their population or their political level to go in one or other direction. And this positive energy, I think, is the thing I much appreciate from the project. We know that we are limited. What we have done is not the solution, but I think that moving in that direction is really nice.
Oh, yeah.
Yeah, thank you so much for an excellent presentation. So you showed a meeting, when all of those communities came together and were sharing their results, and I was just curious, what other opportunities for them to learn from each other? Like that particular symposium, was helpful, but are there other opportunities for communities to do some peer learning or learn how they're approaching the solutions?
This was one of the requests they expressed during this meeting, For a given project, you have a time plan, you prepare and say, we will have the selection process, they start working. Once they have the first results, we do a workshop. When they have the last results, we do another workshop. This is the timeline of the project. We will have another one in December next year, once they get the 3 deliverables done. But it is true that in the meantime, there is a lot of opportunities. And when they were there discussing with each other through the posters, through the presentations, they told us, we need not a help desk as it is now, that it is essentially the people from the project respond to technical questions about how to use the workflow. We need like an ecosystem of interactions to be interacting among ourselves. Don't worry, it's not work for you. You set up all these kind of things and then we work together, no? Or we find who is a way to make questions to the others, how do you solve this or how do you find, and it was not foreseen initially in the project. We are trying to adapt to this request, but it is essentially in the line of what you are saying. Once they connect, what they want is more capacity to connection between themselves.
Thank you, Daniel. That's probably a good way to end for today. We have spent an exciting hour here listening to Daniel and interacting with him. We'll have an opportunity to go next door into 1002 to continue the dialogue with Daniel on stakeholder engagement. How do we do that? What are the difficulties on making things work like that? I really like your last bullet there, that innovative thinking of how the money is distributed. You're not giving it to the universities from the European program management level. You are empowering the communities, the municipalities, to take ownership and be an early adopter, and then select those that can help them, get the next step. So on that note, I think, thank you again, Daniel, for a wonderful presentation. And whoever has time and wants to continue the dialogue with Daniel, we're just going to go next door and continue there. So thank you.